On a windswept coastal terrace in northern Newfoundland, a Norwegian explorer and his archaeologist wife found something in 1960 that nobody expected to find in North America at all. A scattering of rusted iron nails, the faint outline of sod wall foundations sunk low into the grass. For 60 years, this was almost certainly a genuine Norse settlement, the first confirmed evidence of Europeans in the Americas, centuries before Columbus ever set sail. But there was one thing nobody could say with real precision: which year anyone had actually stood there. Then, in 2021, a massive solar storm from 1,000 years earlier, permanently recorded inside the rings of a single felled tree, gave researchers something no radiocarbon test ever could. An exact calendar year, unshakably precise, sitting inside wood the Vikings themselves had cut down with metal tools. For centuries, a set of Icelandic and Greenlandic sagas described voyages to a distant land far to the west of Greenland, a place the stories called Vinland. According to those accounts, it was a land rich with wild grapes growing untended, and wheat that seemed to sow itself without any human hand ever planting it. For most of that time, mainstream scholars simply did not take those specific details seriously. The sagas themselves were treated, by and large, as folklore. Genuine Norse voyages had almost certainly happened somewhere in the North Atlantic. Most historians agreed on that much. But the specific claim of an actual landfall on the American mainland was generally dismissed as poetic exaggeration, colorful embellishment layered on top of real seafaring history by storytellers more interested in a good tale than a precise geography lesson. That consensus held firm for generations, right up until one Norwegian explorer decided to take the sagas considerably more literally than most professional historians ever had. His name was Helge Ingstad, and his wife, Anne Stine Ingstad, happened to be a trained archaeologist, which meant that when Helge became convinced Vinland might actually correspond to a real physical location somewhere along the North American coastline, the two of them possessed exactly the right combination of skills to genuinely go looking for it, rather than simply theorizing about it from behind a desk. In 1960, they set out to do precisely that. They sailed methodically along the coast of Newfoundland, working their way through small fishing communities, stopping repeatedly to ask local residents a very simple, direct question. Had anyone ever noticed unusual mounds nearby, overgrown ruins, anything in the landscape that looked like it might have been built by human hands a very long time ago, rather than shaped naturally by wind and weather? Eventually, that question led them to a local fisherman named George Decker. Decker knew of exactly the kind of thing they were describing, a set of grass-covered bumps rising slightly out of the ground at a place locals called Ons o Meadows. The name itself is worth pausing on for a moment, because it reveals exactly how invisible this site had remained to the people who had actually lived beside it for generations. L'Ons Meadows derives from French, roughly translating to Jellyfish Bay, a name locals had given the area for reasons having nothing whatsoever to do with ancient ruins. For as long as anyone in the area could remember, those unusual grassy mounds had simply been assumed to be a natural feature of the landscape, nothing more significant than an odd wrinkle in otherwise ordinary coastal terrain. Decker led the Ingstads directly to the site, and what began there in that specific stretch of Newfoundland grass would go on to become one of the most consequential archaeological excavations in the entire history of North American history. The Ingstads did not simply glance at the mounds and move on. Over the following seasons, they began a careful, methodical excavation, treating the site with exactly the rigor a potential discovery of this magnitude actually demanded. And what emerged from beneath that grass, piece by careful piece, was clearly not the remains of a simple fishing camp, the kind of temporary shelter that might have been thrown together and abandoned within a single season by local Indigenous communities already well established throughout the region for thousands of years. It was something built by people who had never lived on this continent before. Something constructed according to an entirely different architectural tradition than anything else known to exist anywhere in North America at that specific point in history. Think about what that distinction actually meant, standing there in 1960, watching the excavation slowly reveal foundation after foundation. This was not simply an interesting archaeological curiosity. one more ancient site among many scattered across a continent already rich with thousands of years of indigenous history and settlement. If the Ingstads were right about what they were looking at, they were standing directly on top of physical, undeniable proof that Europeans had reached the shores of North America centuries before Christopher Columbus ever set sail from Spain. That was an extraordinary claim to make in 1960, and extraordinary claims in archaeology have always demanded extraordinarily careful evidence to actually support them. The Ingstads understood that responsibility clearly, and over the following excavation seasons, they set out to build exactly that kind of case, one careful artifact at a time. Excavations continuing through the 1960s eventually uncovered the remains of at least 8 separate structures at Meadows, and their basic architectural footprint told researchers almost everything they needed to know before a single artifact was even pulled from the ground. These were sod longhouses, timber-framed buildings insulated with thick layers of cut turf packed carefully around the frame, an architectural style found extensively across Iceland and Greenland during this exact period, and found nowhere else in indigenous North American construction anywhere in the archaeological record. Think about what that architectural signature alone actually proves. This was not simply a coincidental resemblance, two unrelated cultures independently arriving at a similar building method by pure chance. Sod longhouse construction, built exactly this way, with this specific combination of timber framing and turf insulation, belonged to a very particular Norse building tradition, one that had developed specifically to survive brutal North Atlantic winters in Iceland and Greenland. Finding that exact same construction method reproduced faithfully on the coast of Newfoundland was not a subtle clue, it was close to a signature. But the architecture alone, striking as it already was, did not stand alone as the only evidence recovered from the site. Researchers eventually recovered a bronze cloak pin, a specific style of fastener used exclusively in Norse clothing during this era, a design with no equivalent anywhere in indigenous dress from the region. Alongside it, a stone oil lamp, again matching known Norse designs precisely. A bone knitting needle, evidence of a specific textile technique tied directly to Norse domestic life. And then came the single most decisive piece of evidence recovered from the entire site. Clear evidence of iron production, a dedicated smithy. Iron slag, the waste byproduct left behind when raw iron ore is smelted and worked. And rivets of a very specific type, used exclusively in Norse shipbuilding to hold hull planks firmly together. Think carefully about what that specific combination of evidence actually establishes, because it deserves real weight. Indigenous peoples across this entire region possessed extraordinary skill working stone and bone, technologies perfectly adapted to their own environment and needs, refined and mastered across thousands of years of continuous habitation. But nobody in the Americas, anywhere on the entire continent, was smelting iron directly out of bog ore in the year 1000. That was a specific, complex metallurgical technology arriving from somewhere else entirely, carried across the ocean by people who already knew exactly how to do it before they ever set foot on this shore. It is worth being honest at this point about the actual scale of what the Ingstads and subsequent researchers had actually found, because popular imagination has often significantly overstated it since. This was never a colony numbering in the thousands, some sprawling permanent Norse settlement quietly thriving in secret somewhere in North America. The physical evidence points towards something considerably smaller and more temporary than that. A small seasonal base, most likely housing somewhere between 1 and 2 dozen people at any given time, used for a limited window of activity rather than sustained, permanent habitation stretching across generations. By the 1970s, following years of careful, methodical excavation and analysis, virtually every serious archaeologist examining the evidence had reached the same basic conclusion. This was, without any reasonable remaining doubt, a genuine Norse site. The architecture, the metalworking evidence, the specific artifacts recovered, all of it pointed in exactly the same direction, and none of it could be plausibly explained by any alternative interpretation. What nobody could actually do yet, despite that hard-won scientific consensus, was pin an exact date to any of it. Researchers could say, with real confidence, that Norse voyagers had almost certainly reached this exact spot sometime around the year 1000. But sometime around was, frustratingly, about as precise as the available scientific tools of that era could actually get them, and that particular limitation was about to remain firmly in place for several more decades. To understand exactly why researchers spent decades unable to pin an exact date to Meadows, despite overwhelming confidence in the site's genuine Norse identity, you have to understand precisely how traditional radiocarbon dating actually works, and more importantly, exactly where its real limitations sit. Radiocarbon dating measures the steady, predictable decay of carbon-14, a radioactive isotope absorbed by every living organism throughout its lifetime, whether plant or animal. Once that organism dies, the carbon-14 inside it begins decaying at a fixed, well-understood rate. Measure how much of it remains in a given sample, and you can calculate, with real scientific rigor, roughly how long ago that organism actually died. But here's the critical limitation baked directly into that entire process, one that mattered enormously for a site like this one. Radiocarbon results never arrive as a single, precise year. They arrive instead as a range, a window of possible dates the actual result most likely falls somewhere within. That imprecision exists because atmospheric carbon-14 levels have never remained perfectly constant throughout history. They fluctuate naturally over time, shifting gradually due to changes in solar activity, in the Earth's own magnetic field, and in a range of other genuinely complex atmospheric factors. Researchers have spent decades carefully mapping and calibrating against known historical benchmarks. For a sample recovered from Meadows, this meant researchers could confidently date the site to somewhere within a window potentially spanning several decades, and in some specific cases, a range approaching nearly a full century. Sit with what that actually meant, practically, for researchers studying this specific site for 6 straight decades. They were confident, genuinely and reasonably confident, that Norse voyagers had reached this exact spot sometime around the year 1000. But that confidence came with an asterisk attached that simply would not go away. Did that mean the year 990, or the year 1030, or somewhere else entirely within that same broad window? The available dating technology, as remarkable and genuinely useful as it already was for countless other archaeological questions, simply could not answer that specific question with any real precision. Think about what an archaeological site actually represents at its most fundamental level, because this matters directly for understanding exactly what researchers were missing during those 6 decades. A site like Meadows is not an abstract historical concept, floating somewhere in the vague, undifferentiated past. It is a physical record of real, individual, human decisions, made by specific people on specific days, felling specific trees, cutting specific pieces of iron, building specific walls with their own 2 hands. For 6 decades, that level of granular, individual specificity remained permanently out of reach for this particular site, no matter how much additional excavation work researchers carried out, and no matter how many additional artifacts they eventually recovered and carefully cataloged. Every new radiocarbon test run on material from the site produced essentially the same frustrating result. Confirmation, once again, that the settlement genuinely belonged somewhere within that broad range surrounding the year 1000, but never anything more specific than that. Never an actual year researchers could point to directly and say, with total confidence, this is exactly when someone stood right here and did this specific thing. That gap in precision was never a failure of effort or a failure of scientific rigor on the part of the researchers working the site. It was a genuine, fundamental limitation built directly into the underlying physics of how traditional radiocarbon dating actually functions at all, regardless of how skilled or careful the archaeologists applying it happened to be. Closing that specific gap, finally pinning an exact calendar year to physical evidence recovered from Meadows, was never going to come from additional excavation work at the site itself, however thorough or well-funded. The tool that would eventually make that kind of precision possible was not buried anywhere in the Newfoundland ground at all. It was written instead into something considerably larger and considerably more universal. The sun itself, and the way its own occasional violence gets permanently recorded inside the wood of ordinary trees. In the year 993 AD, Earth was struck by an extraordinarily powerful burst of cosmic radiation, almost certainly the result of a massive solar storm, one of the most intense events of its specific kind ever documented in the planet's recent history. That single event, concentrated within a remarkably short span of time, sharply spiked atmospheric carbon 14 levels across the entire globe simultaneously, all within the boundaries of one single calendar year. To understand exactly why that specific spike would eventually prove so useful to researchers studying a Norse settlement in Newfoundland, you first need to understand something fundamental about how trees themselves actually record time. Every single year, a living tree absorbs carbon dioxide directly from the surrounding atmosphere and locks a measurable portion of that carbon permanently into one single new growth ring, added to the outside of the trunk. Cut that trunk open and count the visible rings, and you are looking quite literally at a physical calendar, one ring representing one full year of that specific tree's life, laid down in careful, unbroken sequence. Now apply that basic principle directly to the unusual 993 AD radiation spike. Because atmospheric carbon 14 levels shot up sharply across the entire planet during that exact single year, and then returned to more typical levels shortly afterward, that specific year left behind an unmistakable, globally consistent chemical signature, permanently embedded inside the growth rings of trees on every single continent affected by that same global atmosphere simultaneously. Researchers can now identify that exact spike with real precision inside tree ring records recovered from Japan, from Germany, and, crucially, from North America as well. Wherever a tree happened to be alive and actively growing during the year 993, that tree's growth rings carry the exact same distinctive radioactive fingerprint, regardless of which continent that specific tree happened to be rooted in at the time. Here is precisely why that fingerprint matters so enormously for archaeological dating specifically. Unlike ordinary radiocarbon dating, which, as already established, only ever produces a broad range of possible years, a cosmic ray event as globally consistent and precisely dated as this one gives researchers something considerably more powerful. One single exact calendar year sitting directly inside the physical wood itself, entirely unmovable and independently verifiable anywhere else on the planet where a comparable tree ring sample happens to survive. The team behind this specific breakthrough was led by researcher Margot Kuitems, working alongside colleagues at the University of Groningen. Their findings were formally published in the scientific journal Nature in 2021, more than 60 full years after the Ingstads had first begun excavating the site itself. And here is the genuinely elegant part of exactly how their method actually worked in practice. Kuitems and her team did not need to recover Viking bone or Viking metal or any additional artifacts at all to finally pin down an exact year for the settlement. What they actually needed was considerably simpler, at least in principle. Viking wood, and specifically wood that could be directly and conclusively proven to have been physically cut down by a Norse settler's own hand using an actual metal blade, rather than wood that had simply fallen naturally, decayed on its own, or drifted ashore from somewhere else entirely on ocean currents. If researchers could locate wood recovered directly from the Meadows excavation itself, wood that still carried the unmistakable 993 AD radiation signature buried somewhere inside its own growth rings, they would finally possess exactly the tool necessary to count forward from that fixed, unmovable reference point, ring by careful ring, all the way out to the very last ring the tree had ever produced before it was cut down and used. That final ring, wherever it ultimately landed, would represent something researchers had been chasing for 6 entire decades, an exact, undeniable calendar year, marking precisely when a real Norse settler had stood on that exact spot in Newfoundland and physically felled that exact tree with their own 2 hands. With the method fully established, Kuitems and her team turned directly to the physical wood samples already recovered decades earlier from the Meadows excavation itself, material that had been carefully preserved and cataloged, waiting patiently for exactly this kind of analysis to eventually become possible. They examined 3 separate wood samples, and all 3 were identified as Fjör. That single identification detail matters considerably more than it might first appear. Fjör did not grow naturally anywhere near the immediate site itself, which meant, quite simply, that this specific wood had been deliberately carried to the location by human hands, rather than felled directly from a nearby forest surrounding the settlement. But the truly critical detail, the one that actually made precise dating possible at all, was something else entirely. Each of the 3 samples still had bark, or the delicate layer of wood immediately beneath the bark, physically attached and intact. Think carefully about why that specific detail matters so enormously to the entire method. The outermost ring on any given tree sample, the very last layer of growth laid down directly beneath its bark, represents the final year that specific tree was actually still alive. Without that outer layer still physically present and intact, researchers would have no reliable way of knowing exactly how many additional growth years might have originally existed beyond whatever inner rings happened to survive. With it intact, they could count with total, unambiguous confidence straight through to the tree's actual final living year. The method itself, once all 3 samples were properly prepared, was genuinely straightforward to describe, even though carrying it out with real scientific precision required considerable care. Locate the unmistakable 993 AD carbon-14 spikes somewhere within each individual sample's growth rings. Then simply count outward from that fixed point, ring by careful ring, all the way to the bark edge itself. The result that came back across all 3 separate samples independently was the exact same year, 1021 AD. Sit with that result directly, because the significance of it is genuinely difficult to overstate. 3 separate samples, analyzed independently, each one landing on the exact same precise calendar year. That is not the kind of result you get from a fortunate coincidence or from a single lucky measurement. That is the kind of result you get from a genuinely sound, thoroughly repeatable scientific method. But the research team was not finished yet, because dating the tree itself was only half of what actually needed to be conclusively established. Researchers also needed to prove, beyond any reasonable doubt, that this specific tree had genuinely been cut down deliberately by human hands, rather than simply falling naturally through storm damage, disease, or old age, and then eventually drifting ashore or being carried into position by some entirely unrelated natural process. The physical evidence settled that specific question decisively as well. Researchers identified clear, unmistakable cut marks directly on the wood itself, marks made specifically by a metal blade. And that detail alone carries enormous weight, because no indigenous population living anywhere in this specific region at this exact point in history possessed metal blade technology of this kind. This was not a tree that had simply died naturally and eventually drifted ashore by pure chance. This was a tree a real individual Norse settler had physically walked up to and deliberately cut down themselves, using a tool that had traveled across an entire ocean specifically to get there. For the very first time in the entire history of archaeological research into pre-Columbian contact anywhere in the Americas, researchers finally possessed something considerably more powerful than a broad estimated range, or a carefully reasoned scholarly consensus built up gradually over decades of accumulated evidence. They possessed one single, exact calendar year, established through an entirely independent scientific method, verified across multiple separate samples, and confirmed by direct physical evidence of deliberate human tool use. Not a range, not an educated estimate, one precise, unshakable year. 1021 AD. Christopher Columbus first reached the Caribbean in 1492, a date most people learn early enough in school that it barely registers anymore as a specific historical fact rather than simple background knowledge. Subtract 1021 from that familiar number, and the resulting gap comes out to 471 years. That specific figure deserves genuine attention because of exactly what it now rests on. This is no longer a rough estimate pieced together from centuries-old saga accounts, dismissed for generations as poetic exaggeration layered over genuine but imprecise seafaring history. It is a number grounded directly in the single most precise date currently established anywhere in the entire field of American archaeology, verified through an entirely independent scientific method confirmed across multiple separate physical samples. But it is worth addressing an honest, important limitation directly, rather than letting that impressive number stand entirely unqualified. The year 1021 AD represents, with total certainty, the specific year that one particular tree was cut down at Meadows. It does not necessarily represent the very first year Norse voyagers ever originally set foot on this continent. Think carefully about what that distinction actually means for how this discovery should genuinely be understood. The settlement itself may well have been used earlier than 1021, established and occupied for some unknown stretch of time before that specific tree happened to be felled. It may also have continued being used for some additional period afterward as well. What researchers have actually proven, with complete and total confidence, is simply this. On that exact year in that exact location, a Norse settler stood on that spot and physically cut down that specific tree with a metal blade. That is the one single moment the physical evidence currently allows anyone to prove with absolute, unshakable certainty. Everything surrounding that specific moment, the full beginning and end of the settlement's actual occupation, remains somewhat less precisely established even now. That honest caveat does not diminish the genuine significance of what researchers actually accomplished here. If anything, it should sharpen exactly how impressive the underlying achievement really is. 60 years of careful excavation, patient artifact analysis, and cautious scholarly argument had already firmly established that Norse voyagers reached North America roughly around the year 1000. It took one single solar storm and one remarkably clever new scientific method to finally pin that broad historical consensus down to one specific, unshakable calendar year. And the significance of this particular breakthrough reaches considerably further than Meadows alone. The same cosmic ray dating technique researchers successfully applied here is now actively being tested and applied to other contested archaeological sites scattered across the entire world. Wherever a felled tree happens to survive with the right specific growth rings intact, carrying its own version of a globally consistent radiation spike somewhere within its recorded history, researchers now possess a genuine, repeatable pathway toward exact year dating. A level of chronological precision archaeology has only rarely ever achieved for sites this old, using any method available before this one. Consider the sheer scale of what that method actually represents going forward, well beyond this single Newfoundland excavation. For generations, archaeologists working with sites this ancient had essentially made peace with permanent uncertainty, accepting broad ranges and educated scholarly consensus as simply the best precision reasonably available for material this old. This new method offers something genuinely different, not an estimate refined slightly further, an actual, exact year, verified independently, wherever the right physical conditions happen to align. What took 60 full years of dedicated excavation work, careful artifact analysis, and patient, methodical, scholarly argument to establish as highly probable one ancient solar storm permanently recorded inside the rings of a single tree 1,000 years ago, ultimately settled with total, unambiguous precision. Not through additional digging, not through some newly recovered artifact pulled from deeper in the Newfoundland soil. Through careful attention paid directly to the wood that had already been sitting in a research collection for decades, waiting patiently for the right scientific question to finally come along and unlock exactly what it had been quietly recording the entire time. For 6 decades, Meadows sat as one of archaeology's best supported claims and one of its most frustratingly imprecise, a genuine Norse settlement nobody could pin to an actual year. It took a solar storm from 1,000 years earlier, permanently recorded inside the rings of a tree the Vikings themselves felled with an iron blade, to finally close that gap. Not a range, not a scholarly consensus. One exact year. 1021 AD, 471 years before Columbus ever left Spain. The sagas that generations of scholars dismissed as embellished folklore turned out to be pointing at something real, sitting quietly in the Newfoundland grass the entire time, waiting on a piece of physical evidence nobody in 1960 could have possibly imagined. The sun itself, keeping a record no human hand ever could. Subscribe for the next investigation.